Today we're going to be explaining this problem over here, where we have it so that we have to find the sum of sine k, where k is equal to 1 all the way to n. So first of all, this obviously means that this is equal to sine 1 plus sine 2 all the way to sine n. That's pretty much just what it means. So what we're going to do is multiply it by sine 1/2. You'll see why we do this soon. So we have a formula when we multiply sine something times sine something else. That is this formula over here. Sine alpha times sine beta is equal to cosine alpha minus beta minus cosine alpha plus beta, all that multiplied by 1/2. So let's put that in each one of these. So we get that this is equal to what? 1/2 times all of this. Cosine 1/2 minus cosine 3 divided by 2, cosine plus cosine 3 divided by 2 minus cosine 5 divided by 2, all the way to cosine 2 and minus 1 divided by 2 minus cosine 2 and plus 1 divided by 2. So let's cancel a bunch of stuff. Everything in the middle is canceled. Cosine 3 divided by 2, cosine 5 divided by 2, and cosine 2 and minus 1 divided by 2, and everything in between, except for cosine 1/2 and cosine 2 plus 1. So now we have another formula for subtracting cosine and another cosine. Cosine alpha minus cosine beta is equal to minus 2 times sine alpha plus beta divided by 2 times sine alpha minus beta divided by 2. So let's put that in, shall we? Well, first of all, we're going to multiply sine 1/2 back on this side over here because, well, it's still on the other side and probably should get rid of it because that's not what we're going to try to find. So first of all, we have this over here, and then by putting this over here, this equation over here, we get that this is equal to oh wait, sorry, I should got rid of this. Sine n times sine n plus 1 divided by sine 1/2. And there you go. That's our answer. In this problem, we have it so that we have to find the sum of the numbers where we have cosine k, and k is equal to 1 all the way to n. So first of all, let's do the same thing that we did last time. Multiply this equation by sine 1/2. The reason that we do this is because sine alpha times cosine alpha is equal to sine something and sine something else. So we can cancel a bunch of stuff. So if we put that in, we get that this is equal to 1/2 times sine 3 divided by 2 minus sine 1 divided by 2 plus sine 5 divided by 2 minus sine 3 divided by 2 all the way to sine 2 plus n divided by 2 minus sine 2n minus 1 divided by 2. So let's cancel a bunch of stuff. So this cancel, sine 3/2 cancel each other, sine 5/12 cancels, 5 divided by 2 cancels, everything in between, and that leaves us with 1/2 times sine 2n plus 1 divided by 2 minus sine 1/2. Now sine alpha minus sine beta will equal to this over here. So now when we multiply both sides by sine 1/2, divide both sides by sine 1/2, because we still have that on that side, we get this equation over here, which is our solution. So something interesting about these two problems is that we can use that these two things over here. If sine 1/2 d is not equal to 0, then when n equals to 1 and it goes to n minus 1, sine a plus nd is equal to sine capitalized n 1/2 times d divided by sine 1/2 d times sine a plus n minus 1 1/2 d. Also, for the cosine version of it, it's sine n 1/2 times 1/2 times d divided by sine 1/2 d. Same thing so far, except this is cosine a plus n minus 1 1/2 d. Just something really you should note about these two problems.